So I have to give the disclaimer. This is hosted by Five Hive. You're not affiliated with College Board, and College Board does not endorse us. And today we're going over the AP Precalculus free response questions. Any questions or anything about that before we start? Nope. I hope everyone's exam went well because it looks like there's 22 people in here, so I hope all of your exams went well. Be getting a 5 on them. But we'll start. So there is multiple solutions. This is just one way to say them. And credits to Mathematic for these possible solutions. So I'll zoom in. There are 4 solutions. Yeah, every person has a different solution, so you can find a YouTube video with a million solutions. No, I mean, never mind. So the first FRQ is your like table and a function. So these are the solutions. Like these are one example of solutions for them. So you could say it's like increasing by equal length intervals, or you could say proportionally. There's multiple ways to say it. So do you have any questions about like how you would approach FRQ1 or any questions like that? Yeah, there's multiple. If you got a different, like any FRQ, you got a completely different set for each FRQ. This was easy, so you all got 6 out of 6. So like, I would assume each of these are 1 point. So this is each like 1 point. So each FRQ is at 6 points. So if you got each of these right, then you got 6 out of 6 on this FRQ. No question about this FRQ? Nope. The next FRQ was FRQ2, your non-periodic context. So it's about a musician, and it said we have t equals 0 was 25,000, and t equals 2 was 30,000. The FRQ1 last part, do we have to put numbers like 1 and 1/2? I think you have to put the 1/2. You don't have to say 1. You could just say it's increasing over constant equal length intervals. Depending on the rubric, it may say 1/2, it may not. They're linear and proportional, yeah. Describe constant proportional, yeah. There's multiple solutions usually. Oh yeah, this one doesn't have an no, it has an inverse function. The other FRQ, the unreleased one, did have more inverse functions, but yeah. So the next part was FRQ2, which gave us a few numbers, and we had to make a quadratic. So and this would be 1 point, this would be 1 point, and I would assume each part is 1 point as well. College Board just takes proportionally changing, gives you the point. Depends on the rubric and who your grader is, but yeah. The quadratic, yeah, usually there's a quadratic, exponential, and a log slash natural log equation for each version. Yeah, there was another one that was also log. There's one for each every year. So the solutions, this would be the solutions. The first one, you would just make 3 equations and you would solve them. You check the second order difference. There's only 3 points. There's only 3 points. 0, 2, 4, 25, 30, 34. And he meant that he got a different version, like not the released one. Like, so you would solve. Some people were saying in the AP Precalc channel you could use regressions, yeah, or Desmos, you could do that. But it's always safest to show your work. So if you mess up one, they'll give you the points for the other based off work. And it shows you how you solve it by simplifying it to like A or B and then plugging it back in and then solving and plugging back in. B, you have to use D for, and then you have to find the rate of change, which was 2.25 thousand songs per minute. And then you would plug in, and then you would say the secant line, because that's an important vocab word. And then you would say it's underneath the curve, so it's actually less because it underestimates. And then the total number of, and then you would say for the last one, which is like determine how the minimum and maximum can be used to determine boundary for the domain. You would list the domain and you would say cannot decrease because it's always strictly increasing. And if you said all those like key parts for both of these, you would get all the points. Does that make sense for FRQ 2? Yep. For the next FRQ, we have FRQ 3, our periodic context. It says we have T0 and we have 2 millimeters above, and it says 2 millimeters below, and it says the motion occurs 200 times in 1 second. And if it says in 1 second, it's your frequency. Yep, and if you have if this value and it says this is sine function, so if this is your 0 value, then you don't need a phase shift. So in this example, they said 200 cycles in 1 second, and that's your period. And they said 0 to 1 800, 1 400, 3 400, and 1 202. And then you can find your values based off that. Find your period, find your shift, and you find this. And then you can say it says from T1 to T2, and that's from G to J. It's because this is 0, so it's negative, so it can't be these, and it's decreasing because the function, it says the function, not the rate of change. And yeah, it's always better just to write as a fraction instead of decimals because they're easier to divide by. From 100, I put coordinates from 100 to it says so the cycle is 100. So if you said this is 0, your next point would be here 1 200. So then this would be 1 400, and this would be 1 800. Oh yeah, it can't be T 100, 200 like that. Be something like this. Does that make sense? No, read the problem since that would not work since T equals 0 has to be the midline. Yeah, this has to be 0. Yeah, it's kind of hard that it's been a while since the FRQs. Can't have, you could have 2 to 800. It doesn't have, no, you could, it doesn't have to be simplified. Yeah, they're usually lenient about that, like simplifying. Unless it's like a simplifying question. But yeah, the teacher is usually grade stricter, so then you're over prepared for the exam. Yeah. And then you says D negative decreasing, and then you say it's concave up because this is concave up. And the rate of change is increasing because it's concave up. Yeah, this FRQ seems pretty light. And then this one, FRQ 4. This is your solving. This is your this, and the way you would solve this is you would say E of x is going to be equal to like y or any variable, and you would say y of 2 minus y minus 12, and then factor and then plug back in E of x at the end. Then you get your two factors. For this one, you would just use your trig properties and simplify. And for these, you would just say like 4 equals 2 log 3 of x, and etc. And these would be your canonical solutions. 0 pi pi. It was 2 pi instead of pi over 2. Hold up. So it was 2 to 2 pi instead of it says pi over 2. It's pi over 2. That's an interesting interval, but yeah. You would say 3 over 4 is equal to cosine squared theta divided by 4. 3 over 4, square root both sides, you would get square root 3 over 2 equals cosine of x. Do you know what physics 1 debrief is? No, I do not. That would be a question. Yeah, I don't know who the question would be for. And these would be a solution. So pi over 6, 9, log 2 of 8 of x, and ln of 4. And you do not have to simplify like other people are saying into like 2 log of 2 ln of 2 like people are saying in the channel. You don't have to simplify into this far. You can leave it at x is equal to ln of 4. Because this is a specific value that you can plug into Desmos and get an exact value. We go back to quadratic one, short. The quadratic one. So these would be your canonical solutions. Like, do you guys state that e of x equals -3 isn't? No, just you have to leave the final solution. You don't have to state that it's not a solution because they'll assume that it's not a solution if that's not your final solution. If you don't simplify it. Or say x is equal to that. For whoever wanted to see FRQ2, the quadratic one, these would be the answers. Did you use point slope? Yeah, for this, I would say the best way to do this would be point slope. Yep, best way to do this would be point slope. Yeah, I can show FRQ1 after. Any questions? Love Fitty on this one. I can post these solutions in. Post these solutions real quick. Here you go. Alright, and FRQ1. FRQ1 was these are the solutions. It's first, it says h of 1, so you start with this 1.75, and then you would plug 1.75 into this. For this one, you would just use Desmos and say where is it equal to the zeros pretty much. For this one, it's going towards -infinity because it's a cubic, so it's going like this. So it's going, as it goes to infinity, it's going -infinity. And this says for part C, based on the relationships, it says based off this, what's this table? And if you did your this, and you would see that it's dividing by 2. So it's exponential and it's increasing or by a constant equal change intervals, outputs change proportionally by a factor of 1/2. Does that make sense? And any other questions? Any other questions about the FRQs or anything pre-calculated for the they will not release the MCQs because they reuse them. So that's why we're not allowed to talk about them either, because they use them again. Sometimes some of them get released back into like AP Classroom, and that's how they get like those practice tests and stuff. But most of them just get reused through every year. What about the next set? What do you mean, like FRQ sets or MCQ sets? FRQs like the other versions. They won't release any other FRQs. Whatever FRQs they post is the FRQs they will post. So if you got a different version except these four, then good chances you won't see them again unless one day you find these, unless like one day they release like a practice test of these FRQs. But yeah, like similar to how like 2024 like they posted all three versions, stuff like that is the only way you'd see the other versions of the FRQs. And that's it for the FRQ debrief. So I'm gonna end the recording and then